All right, so in this lesson, we're going to be identifying and finding equivalent ratios and just kind of working from there to solve some problems. We want to represent equivalent ratios in tables, but also as points on a coordinate plane. We want to use those equivalent ratios in the tables and those graphs on the coordinate plane to help us solve some problems as well. So let's take a look at our first problem. Why don't you go ahead and read it, try to figure out what's this problem about, and then try to answer the question based on that information. Go ahead and pause this video at this point and try that out. Okay, so a streaming music channel always plays the same ratio of pop songs to hip-hop songs. The point on the graph shows the number of hip-hop songs played for every 3 pop songs. And you can kind of see that here. For every 3 pop songs, there are 2 hip-hop songs. Based on the relationship in the graph, how many hip-hop songs does the channel play for every 12 pop songs? Well, let's take a look at this. There's a few ways to do this. And hopefully you've got one of these ways. Maybe you tried a different way that we'll cover a little bit later on in this video. Okay, let's go ahead and move on here. You can actually make a table out of these values and equivalent ratios from the ratio that we already had. That ordered pair, 3, 2, shows that there is a ratio of 3 pop songs to 2 hip-hop songs, a 3-to-2 ratio. Right, so we just kind of put it into this table here. Our pop songs, which will be represented by the variable x, and hip-hop songs represented by the variable y. The x and y will become a little bit more clear on our next slide. But we started off with a 3-to-2 ratio and basically just increased by 3, because for every 3 pop songs, there are 2 hip-hop songs. So over here for our pop songs, we just keep on increasing by 3, but every time we increase the pop songs by 3, we increase the hip-hop songs by 2 to keep them equivalent. So there we get a 6 pop songs to 4 hip-hop songs, then a 9-to-6 ratio, and then a 12 to what? Well, if we added 2 there, it would be a 12-to-8 ratio. Another way to look at it is through a table. Again, what we need to do in today's lesson is to make sure that we know how to make these tables, but also make these graphs and solve problems using those. Right? In this case, we started with the plotted point 3, 2, and for every 3 pop songs that were played, 2 hip-hop songs were played, placing us at a 6-to-4 ratio. And then we increased that again for every 3 pop songs. There were 2 hip-hop songs, giving us a 9-to-6 ratio. And the question was for every 12 pop songs, how many hip-hop songs, right? So we increased it by another 3. That gets us to 12 pop songs. Every 3 pop songs increases our hip-hop songs by 2. And that places us at this point here, which is a 12-to-8 ratio, or as an ordered pair, 12, 8 as a location on our coordinate plane. So now we have a 12-to-8 ratio. That's 12 pop songs to 8 hip-hop songs. So how does the graph in the problem show that the ratio of the pop songs to hip songs is 3-to-2? It's referring to that first graph right here. Right? This is a 3-to-2 ratio because we're talking about 3 pop songs for every 2 hip-hop songs. It says to look at the table in the first, model it, and the graph in the second. How is the addition pattern in the graph related to the addition pattern in the table? So you remember over here for our pop songs, it was for every 3 pop songs, there was an additional 2 hip-hop songs, right? So our x values are going to be increasing by 3 while our y values are increasing by 2. And you can see that happening here as our x values represented by on our x-axis, as our x values increase by 3, our y values are increasing by 2. And we just kept that pattern going over and over, and we could continue it to figure out other problems. Number 3, how many hip-hop songs does the music channel play for every 12 pop songs? Well, that was 8, right? That was 8 You can see that here, 8 hip-hop songs for every 12 pop songs. It says to plot a point on the graph to model this relationship. I did that already right here, so you should do so as well. Number 4, how can you use a point on a graph to find another point that represents an equivalent ratio? On a graph, right? So specifically talking about on a graph, how can you use a point on a graph to find another point that represents an equivalent ratio? Well, we kind of did that here, right? We basically just took the x value and increased the x values by that, and then we took the y value and increased the y values by that. So as long as you're increasing the x values and the y values by the same amount, starting with the ratio that you're already given, you should be good. We increased by 3 because my x value was 3. We increased by 2 because our y value was 2. And we can keep on doing this pattern to find an infinite amount of equivalent ratios. Number 5, how could you use ordered pairs and multiplication to find equivalent ratios? Well, let's take a look at the ordered pairs. We started off with a ratio of 3 to 2, or 3, 2 as a ordered pair. And we went to a bunch of others, but let's just, for the sake of this, we went to a 12 to 8 ratio, right? We already knew that we wanted to go from 3 to 12. So the question really is this, is given just the ordered pairs, the question was asking this, what goes here if these are equivalent ratios? Well, how do you go from 3 to 12? Using multiplication. That would be multiplying by 4. Well, then what in the world did we have to do here? We also had to multiply by 4. And 2 times 4 gave us how many hip-hop songs we would have for 12 pop songs. So we can just use the multiplication to get us there. You could also use that repeated addition, but remember, repeated addition is just what? Repeated addition is just multiplication, right? So how many times did we had? We had to add 3 times, but we started with a 3 here. So 3 plus 3 plus 3 plus 3, which was adding 3 4 times. So we could have just said 3 times 4. Same thing over here. We started with a 2 plus 2 plus 2 plus 2, which is adding 2 4 times, or just 2 times 4. So again, we can just use multiplication. We can actually find another one. Let's say I had 3 pop songs to 2 hip-hop songs, and I wanted to ask you, well, I'm going to play 21 pop songs. How many hip-hop songs would that be? Well, this is times 7, so we would have to also multiply by 7 on this side. That would give us 14. That'd be a 21 to 14 ratio. I'll go ahead and let you pause the video here to think about all the models and the strategies we discussed. Describe how one of them helped you. Did the table help you more? Did the graphing help you more? Does multiplying these ordered pairs help you more? And just kind of talk about how that helps you understand what we discussed today already. And then at this point for number 7, the ratio of the length of a fire hose in feet to the number of gallons of water the hose can hold is 100 to 4. And you can see that represented on the table here. That would be the ordered pair, 100, 4. It says to complete the table of equivalent ratios, then write the ratio as the ordered pair. So we basically just want to fill in all the blanks. I'll do one of them, and then I'll pause the video to let you finish. The easiest one here probably, maybe here. We know that this had to go from 50 to 100 is to multiply by 2. So we had to multiply by 2 to go this way, right? So 2 times what is going to be 4? Well, this would have to be 2 then, right? So a 50 length hose can hold 2 gallons of water. So that is a 50 to 2 ratio. So what in the world would have to go here? Well, what did we have to multiply by here? Well, 1 times 2 would get us to 2. So what times 2 would give us to 50? Well, that would have to be a 25 length hose, right? Now be very careful on this next one. I should probably do this. That's going to be a 25 to 1 ratio. Not by what we multiplied by. It's our 25 to 1 ratio. And then lastly, how did we get from 4 to 12? That's not times by 2 this time, so we're actually skipping an equivalent ratio here, but that's okay. We had times by 3 to go from 4 to 12. 4 times 3 is 12, so then in our ratio over here, we just times by 3 to get 100 times 3, which is 300. And that's probably the trickiest of the ratios here. So this is a 300, comma 12 as an ordered pair. All right, go ahead and try this one on your own. Read it through and do it. You notice I put a star down here. That means something, right? It means it's important. You're probably going to see it again. Enrique has a container of 32 fluid ounces of orange juice, and he's filling glasses with 1 cup of juice each. The point on the graph shows the ratio of fluid ounces to cups. So this right here is showing orange juice in ounces, 8 ounces to 1 cup. Based on this ratio, how many glasses can Enrique fill from the container? Now, this problem wants us to specifically use the table. We could use the multiplication method as well with our ordered pairs, but remember that we also need to be able to use an ordered pair and a graph, a coordinate plane to show this, right? So we could actually continue this ratio. Remember that we are going to use 8 and 1 to keep on moving to the right and to the left. So for every time I move right to 8, that's 8 ounces, I am pouring 1 cup. So let's pour another 8, and then another 1, another 8, and then that gives me 1 cup. 8 ounces to 1 cup, right? So that's a continuation. So we had 8 ounces for a total of 16 ounces, another 8 ounces for a total of 24 ounces, and another 8 ounces for a total of 32 ounces. That's all we have. So how many cups did we pour? Well, that means we poured 4 cups. So an equivalent ordered pair or ratio would be 32 to 4. So how many glasses can we fill? Well, we can fill 4 glasses with, this is our glasses, right? With 32 fluid ounces, right? That point would be right here. We can mark it here, 32 comma 4. So our answer is just 4 glasses. And I used a table to do so. The other way that we could have done it is started with the ratio given, 8 comma 1. We needed to pour 32 ounces. To get up to 32, we have to multiply by 4. So to find our unknown glasses here, we can just multiply by 4, giving us 4. Now I want to do table and coordinate plane. So I know it says exit ticket. This isn't the last problem you'll be working on. It's the last one I'll be covering in this video, though. Pause the video, see if you can fill in the table and plot all the points on the graph. See if you can do it yourself, and then check just here for the answer. Every 4 ounces serving of Yum's yogurt contains 8 grams of protein. Complete the table of equivalent ratios, then plot the point on the graph to represent the ratios. Well, this is interesting. It didn't give me one, right? It says every 4 ounces to 8 grams of protein. Well, it kind of did, didn't it? So we already have 4 ounces to 8 grams of protein. How can we get from 4 to 8? Well, that would be multiplying by 2, so we're going to multiply by 2. How do you get from 8 to 12? Well, you might not know that, but let's look at this from a different perspective. Let me get my eraser up in here for a second. What if instead we talk about how we go from 4 to 12? Well, that would be multiplying by 3, right? Sorry, 2 times 8 is 16. That should be a 16 here. So instead of figuring out how do we go from 16, instead of talking about this, 16 to this number, we're actually just going to go from 8 to 12 and multiply 8 by 3. 8 times 3 is 24. Okay, I'll give that eraser out. I'm going to clear up some of these markings here. Let me just kind of start here and go all over that again. Make it a little bit more clear with my writings. So this was given. Multiplying by 2 to get to here. So this is going to be 16. To get from 4 to 12, that's multiplying by 3. 8 times 3 is 24. And then you can say 4 times what gets us here? Well, we don't know, but 8 times 4 gets us to 32, right? So it's times by 4, so that's going to be 16. You also might see that we're just adding 4 each time here, right? Adding 4, adding 4, adding 4. And over here, we're just adding 8, adding 8, adding 8 to get up to 32. So we're going to go ahead and plot these points. You also probably could have went straight to the table, starting at 4, comma 8 would have been right here. So this is at 4, right? And this is 8. This would be 12, 16, 20, 24. This would be 20. We're adding by 4 every time here. On here, this is 4, 8, 12, 16, 20, 24, 28, 32. You weren't sure about all those intermediate markings. So we have a 4 to 8 if this is our x and our y. 4 comma 8 is here. That means we'd have to move over 4 and up 8 to get to here. Over 4 up 8, over 4 up 8. And you can see how these points are all here. We have 4 comma 8. Get out a different color here. 4 comma 8 right here. We have 8 comma 16. Right here we have 12 comma 24. And right here we have 16 comma 32. And you can see how these ordered pairs from this graph relate to the ordered pairs over here in this table. So if you got that right, you're doing really well. If you needed some fixes, hopefully you got the understanding. Let's move on. For the rest of the examples here for your practice, it'll be your green pages in your book. I would like you to do on your own. You can check with a neighbor. That's perfectly fine. And then when you're done with that, you have some homework you can go work on your MyPath. Okay, so go ahead and do that. Make sure you're doing your best in class. All right. Thank you so much. Have a good one.